we're going to go ahead and take a look at addition and subtraction of fractions. And so addition and subtraction of fractions, we can look at in multiple ways. A region model, for example, 1/5 plus 3/5, we can look at a region model. We can look at a number line to do that. Or we can look at fraction strips. Again, they're all representing these fractions, 1/5 and 3/5, and another way to kind of look at it, as you combine them, you end up with a new value. And so this idea of 1/5 plus 3/5 is 4/5 is because you have 4 groups of 1/5, which come from here, right? We learned in the last section that 4/5 is 4 groups of 1/5, or 4 times 1/5, 4 of 1/5, and that you see that when you do 1/5 plus 3/5. Fractions with common denominators is the easiest way to add fractions because they're the same relative unit amount, meaning that the denominators are the same. So in this case, 3/5 and 4/5 is because you had 1/5 in this case, plus you had 1/5 plus 3 groups of 1/5, right? And so that's where you get you had 1 group of 1/5 plus 3 groups, and there's your 4 groups of 1/5. And so that's why you just add the numerators when the denominators are the same. How about when the denominators are not the same? 3/4 plus 1/2. So you can take a look at this, and as you look at this, we can't just combine them together or say now that this answer equals 3/6. Just doesn't work that way. The visual gives you that I can't do that. And so how do you add that? You have to use the unlike denominators theorem, right? One shortcut would be, here is finding a common denominator, but one way to do that using that formula on the bottom, right, is follow the formula. So a times d is on top, so you get 6 plus 4 times 1 is 4, all over on the bottom. B times d is 8. And so there is your 10/8, which again is not the same as 5/4. It is the same as 5/4. It doesn't look like it, but you would reduce it. So in order to add fractions, you could use this formula here, which is a formula. You just follow the rules. Or as we start to learn is that you want to put them into, so that they have the same, what's called common denominator, right? And so to add fractions with unlike denominators, find equivalent fractions with common denominators, then sum will be representative of the sum of the numerators over the common denominator, and that's this method here versus the formula. But the formula works all the time. And sometimes in algebra it's good to use the formula instead of finding a common denominator. So students, you want students to know both ways. And so looking at these problems here, the sums of fractions, you see common denominator, easy, just add them. Here they need a common denominator, so you can find a common denominator here, which would be 36. And notice I had to multiply the top, this one by 4, this one by 9, and so you end up with a common denominator. Now that they have a common denominator, I can just add them per the formula. We could also, in this case here, on part C, 2 ways, we could also have done the cross multiply. 17 times 12 is 204, 15 times 5 is 75, 15 times 12 is 180, and then add them. Or again, using a common denominator approach, you can see what we get, and then this would then simplify into 93 over 60, which actually simplifies further. I know 3 goes into that 31, and 3 goes into 20 times. So this would also then be 31 all over 20, since 3 goes into both of those. And so fraction for addition has the similar properties that fraction of whole numbers have. Closure, commutative, identity, right? And a fraction plus 0 is itself. Associative property, you can move them around to do that, which then allows you to kind of finalize this stuff here. Just moving these around, 3/5 and 2/5 go together. 5/5, that's a 1, so you get 1 and 4/7. Otherwise, again, you would have to find common denominators here to do that. You can add those together and you get the same answer. Now looking at this last piece here, I don't want you to breeze through this. This improper fraction, 3 2/5 is the same as 3 plus 2/5. That's why it's important. So that's how you convert a mixed number to improper fraction. Really what you're doing is converting the whole number into a fraction, right? You're breaking it up. And then the 36/7 is a mixed number. You'll see, right, 36 is 7 times 5 plus 1, so that's why it's 5 1/7, or use long division to do that. 36 divided by 7. 7 goes into 36 5 times, remainder 1, and so 5 1/7, right, is what you have. But important to recognize this improper fraction can be broken up into two pieces here. And then you end up with that, which again, the shortcut is to basically say 5 times 3 is 15 plus 2 is 17. But that's a shortcut again versus breaking it out by hand.